This is Pure 1, chapter 5.5, the last chapter of straight lines. If you know Browser from Mario, the final boss for Mario, same thing for modeling with straight lines. Modeling is the final boss for the straight lines. Students sometimes have issue applying straight line equation into modeling question, but don't fret, I'm here to help you go through how do we get into modeling mode, okay, to answer some of those questions. Before we begin, let's have a look at some examples of the linear graphs that represent real-life data you've learned in GCSE, primary school, other subjects, science, etc. Scatter graph, we can use a line of best fit, that's a straight line. Time series, you can see it's made up of many straight lines. Ignore this part, it's a bad drawing. It's not meant to be a curve. I think about stock market, something similar. Distance time graph, straight lines, even though it's not, if we know our physics, if we know our science, we know it's unlikely to be a straight line in real life. But anyway, for simpler model, it could be a straight line. So modeling straight lines simply means the axes are changed from x and y to a different context. In distance time graph, you can see the y-axis becomes distance, the x-axis becomes time, and here's time as well. Scatter graph, you can think about, again, maybe age and IQ. Yeah, if probably that doesn't sound right, because as you grow older, the IQ goes down. I don't know, maybe for some people, maybe some people like me. Right, okay, anyway, moving on. Right, so some question, okay, generic question to help you get into modeling mode. This will usually be asked inside the questions, but nevertheless, it'll be useful for you to think about these questions before you tackle any question, modeling questions. How do you know it's a modeling question? You will know, because the questions usually are quite lengthy. Anyway, so what are the new labels on the axes? All right, what do the x and y axes represent? Second question, what does a gradient mean? Okay, so what's a gradient mean, and what does a y-intercept mean? In here, we'll learn a sentence structure to write down a gradient and a y-intercept. Okay, so you can leave the space in here. We can come back to this later. Okay, right. Let's have a look. First one, the graph shows the extension E of a spring when different masses M are attached to the end of the spring. So first question we get into modeling mode is, what does the x and y axis represent? Now you can see the x-axis represent mass. So x-axis is the mass, okay? And the y-axis is the extension. We use E and use M in here, okay? Question A, calculate the gradient of the line. So to calculate gradient from a graph, you've learned from GCSE, you pick 2 points and you work out gradient. So in here, question A, I'll pick the point 0, 0 and the point 105. Or you can draw a little right angle triangle, whichever works for you. The gradient. Now, normally we use a letter M for the gradient, but we can't use it in here because the M is used for the mass. Therefore, they use a K. So K is a gradient. So K equals 5 y2 minus y1 over x2 minus x1, which is 1 over 20. Okay, so that's the gradient. Question B, write an equation linking E and M. So question B, linking equation. Now, this is a straight line, right? Straight line, we've learned a formula, which is y minus y1 equals mx minus x1. Or you can use the baby formula, the y equals mx plus c. In this case, we are not going to use the y and m because we don't have y and m. We don't have y and x in here. We don't have the gradient, it's not m. We have to use the correct letter. So the y will be the e. So e minus e1 equals m, which is the k of m minus m1. A bit weird, but anyway, you get it. So what we need is the gradient again and the point. We have got a gradient, so the gradient, to stop confusing you, the gradient k equals to 1 over 20. We need a point. The point we can use 0, 0, which is your E and M. Okay, so that's your E and M. Okay, so we're going to use the formula. So E minus E1 equals K 1 over 20 of M minus X M1. So essentially, it's just E equals 1 over 20M. Okay, next one. So part C. Okay, part C. Explain what the value of K represent in this situation. So K is the gradient. Okay, so if you think about in GCSE, okay, gradient. Okay, so gradient equals difference in y. When we use difference, sometimes we use triangles. The difference in y over difference in x. A triangle means a difference. Oh, Greek-wise, it means delta. Delta means difference. So yeah, so this one here is delta. Like we talk about pure mathematics sense, the triangle means delta, but in here it means difference. Delta, you see, oh, what's a delta? What's a delta? It means a difference in sometimes people use this term in financial world as well, delta, but difference y over difference in x. What does it actually measure? It actually measures the rate of change in y over x. Now this will be the key sentence when it comes to the gradient. Okay, so k is a gradient, so k measures. Okay, so k is the gradient. Now you're gonna write this down. This is the formal answer, which represents the rate. Now it's a positive gradient, so it's the rate of increase. Okay, so it's the rate of increase, right? Of y. What's y? Y is the extension of the string. So extension of string over the mass x. Okay, so learn this sequence, learn this sentence structure. So it's the rate of increase of the extension y over x, right? So if you go back to your previous, go back to your steps in here, what does gradient represent? So learn this sentence structure. It represents the rate of, okay, so it can be the increase or decrease of the y value, so the y over x. That's the sentence structure for gradient. Now, they like to ask you that for the 1 marker in the exam question, in the modeling question. So remember that. It represents the rate of either increase or decrease. Pardon my writing, my scribbling. It's not writing, it's scribbling. The rate of increase or decrease of the y, whatever the y is, over the x. So about technical issue there. Right, so yep, okay. Now I want to add one more question in here, which is part D. So if you can add one more question for me, okay, part D. Right. Oh, actually, there's no y-intercept in here. Ignore me, sorry. Just ignore me because the y-intercept is 0. Actually, it'll be tested on you for you next question. So right, have a go, practice question 1. Leave question B with me, okay? Leave question B and D with me. So leave B and D with me, okay? So have a go, question A and C, all right? When you're ready for the answer, you can press play. Right, so here are the answers. For question A, you should get D equals negative 0.13t plus 19.1, and for part C, you get T equals 147. So in here, we're asking 2 questions again. First question is, what's the x value? What is x? X is time. And what's y? Y is depth. Okay, so that's your y equals mx plus c equation here. So all we need is to find a gradient first. To find a gradient, they use the gradient is difference in y over difference in x. So we just pick 2 coordinates from the table. So it'll be 17.8 minus 19.1 over 10 minus 0, which you'll get is negative 0.13. And hence, 0.13 is here. Okay, and the y-intercept is 19.1. So therefore, plus 19.1. So D equals negative 0.13t plus 19.1. I'll skip B for now. Okay, so that's part A. Let's go for part C. Find a model of the time. Use a model to find a time when a container will be empty. Now there are 2 variables in here. The 2 variables are time and depth. Okay. Now here's a skill. If you want to find time, okay, then surely you must know depth, because otherwise you won't be able to find time. So therefore, whatever information given to you next will be about the depth. This is some exam technique or some thinking skill. Not a lot of teacher will teach you this way. But in here, we'll find time. That means we must know depth. Will be empty. That means the depth equals 0. So question C, okay, when D equals 0. So when D equals 0, 0 equals negative 0.13t plus 19.1. Then 0.13t equals 19.1. T equals 19.1 divided by 0.13, which gives you 147 seconds, okay, as required. Right, part B. So let's go through part B. Okay. Now, can I invite you to write down? Okay. So we know interpret the meaning of the coefficient of A and B. A represents a gradient. So can you use the sentence structure which we just learned to write down the meaning of A? Okay. Pause the video. Have a go. So I'm not going to write out because of my beautiful handwriting. Instead, I'm just going to type it out. So let me use a different color. Okay. Right. So question C. Right. Question B. Right. So A represents the gradient, which represents or A is the gradient, which represents the rate of. Now you can see the numbers going down. That means it's the rate of decrease. It's the rate of decrease. So it's the rate of, oops. It's a rate of decrease of Y. So what's Y? Y is depth of water. Depth of water over X over time. Okay, so represent the rate of decrease of water over time. Now, B is the y-intercept. So what is the y-intercept? The y-intercept is x is 0, right? Y-intercept means x is 0. So when x is 0, in this case, x is time. That means time is 0. When we use the word time is 0, we use the word initial. Okay, so when x equals 0, that means the y-intercept. So B is the y-intercept, which represents the initial depth of water. So learn this keyword, initial. Okay, so we represent the initial, the y. All right, so let's go back to this one here. What does the y-intercept represent? Okay, the y-intercept, okay, represents the initial, keyword initial y. So whatever the y is, the y-axis represent the extension of spring, then it'll be extension of spring. The y represent bacterial growth, initial bacterial growth. Y represent the height, initial height. In this case, represent the initial depth of water, Okay, right. Part D, state one limitation to the model. So part D, limitation to the model. Now, think about long run. What happened then? Okay. Now, when it comes to limitation, think about long term. Okay. The model is working so far. Okay. So we have got some data on the top in here. You can see it's working so far. But think about long run. What happened? T becomes a very big number. Let me invite you. Put in a calculator. What happened if you substitute a very big number into T in here? Put in a calculator. Let's say 10,000 million. You realize what's the problem? D becomes negative. But D is the depth of water. So depth of water cannot be negative. Therefore, that's a limitation. So what's the limitation? The limitation is, okay, the limitation is that the model predicts a negative depth of water at some point. Now, to be more specific, you don't have to write this, but to be more specific, that is after 147 seconds. Because we'll work it out in part C. Normally, you don't have to work it out, okay, after 140 seconds. That's why, okay? So because when 147 seconds, the depth is 0. That means if we go on 148th second, it becomes negative. So obviously, you can't have a negative depth of water, okay? Right. But, you know, your bank account could be negative. Just be careful. Don't go bankrupt. So, right, next one. Okay, example. Jolene, an ex-student of mine. I don't know if she's an app designer. I just make it up, username. Hopefully she doesn't mind. An app designer charges a fixed amount for the initial design work and an additional daily rate for any revision requested by clients. Company X app designs takes 4 days and they charge £1,500. Company Y takes 8 days and charge £2,400. Write an equation linking number of days and total cost in the form of C equals AD plus B. So where A and B are constants to be determined. Right, so part A, okay, so we know C equals AD plus B. Our task is to write down, first of all, what does X and Y represent? The X is the days, okay? And Y is the cost, C. So therefore, Y equals AD plus B, what you know is this is your gradient, and that's your y-intercept, y-intercept, okay? Right, there are two ways you can do this, okay? The first way is you can change the information from the question to a coordinates and work with a gradient that way, okay? Here I'm going to show you a more sort of, again, a high level, more advanced level way of doing things. That's what we normally do, which is substitute in there. So 4 days and 1,500 means D equals 4 and C equals 1,500. So what we're going to do is go substitute, okay, D equals 4 and C equals 1,500 into the equation. You get 1,500 equals to A times 4 plus B, which give you 1,500 equals 4A plus B. Next, you can also do the same thing for the second line in here. That's D equals 8 and C equals 2,400. So we're going to substitute D equals 8 and C equals 2,400. So 2,400 equals A times 8 plus B. So 2,400 equals 8A plus B. And then guess what? Simultaneous equation. Okay, simultaneous equation. Now, you can use a calculator. Remember, once you've got the interval calculator, you can use a simultaneous equation function in the calculator to solve it for you. If you forgot where it is, it will be in the menu, and then go into equation function, which is usually around the A tab. And then there you should ask you about polynomial or simultaneous equation. Simultaneous equation is what you need. Okay, put it in there, then you should get A equals. Let me use my mental maths. I'm just getting my answers. Is that A equal to 225 and B equals 600. Remember, in the exam, you don't get any marks for showing how to do simultaneous equation, how to solve linear simultaneous equation. So, right, anyway, what's the method 2 I was talking about? Method 2 I was talking about is that you can make the D equals 4 and C equals 1,500 as a coordinate for 1,500. And then also you've got 8 and 2,400. You can work with the gradient using y2 minus y1 over x2 minus x1. And then that should give you, was it 225? It is 225, right? Hopefully it should be 225. And then use C equals to 225A, nope, 225D plus B, because I'll think about y equals mx plus c. And then normally, if you want to work out the C value, which is your B in this case, you will sub a point. So you substitute a point, maybe 1,500. So 1,500 equals 225 times 4 plus B. That should be 900. So B is 600. You can say the same thing. Okay. Right. But read the question, part A. We're not done yet because the question wanted to write an equation, linking number of days. So what we need to do is the final step, which is to rewrite the whole equation. So C equals to A D plus B. Now, without this final line, you will lose the mark at the end. Okay, so read the question. Right. Part B interprets the values of A and B. You should be able to interpret now. Okay, so pause the video, have a go. Okay, if you're struggling with it, have a look into what we did in the previous example and the sentence structure that we use. Okay, when you're ready for the answer, you can press play. So hopefully you should have the answer. A is a gradient, which represents the rate of increase of the y, which is cost over day. But over day doesn't sound grammatically correct. So over each day or per day. Okay, so you can say per day. Or it's basically daily fee charged. How do we know that? Well, it's actually given for you by the question. It's a fixed amount of initial work and daily rate. So it's essentially it's daily rate. And B is the y-intercept, which represents the initial, the y cost. Okay. C, part C. Jolene charged a third company £17,025. Calculate the number of days she's been spent working on the app. So again, the two variables in here are C and D, the cost and the days. They want you to work out the days. That means you must know cost Well, you should know because they gave you the pound sign. So you should be able to refer or to link this information to C equals 17,025 pounds. So this is what we're going to do. Okay. Part C. When the cost equals 17,025. So we're going to use the equation 17,025, C equals A 225D plus 600. Rearrange the equation. Okay, so take away 600 on both sides and then divide by 225. So, well, 17025 minus 600 over 225 equals D. Essentially, make D the subject. Put in the calculator, you should get D equals 73 days. All right. Oh, I love my days. You know, how I write it. It looks fancy, isn't it? Anyway, so pause the video. Okay, exam practice for you. Okay, it's nothing different to what we just did for the example. So pause the video, have a go in the question. When you're ready for the answer, you can press play. So this is the final answer. Okay, so first of all, we know we can set the equation V equals MD plus C because Y equals MX plus C. So Y is V, your X is D. Okay, so V equals MD plus C. So in the first line here, 40 liters, that's V, and 80 kilometers, that's D. So when V equals 40, D equals 80, we make an equation. So 40 equals 80M plus C. The same thing in here, 25 liters V, and this one is D. So we sub it in, we get two equations, simultaneous equation, put in the calculator, get M equals -1/8 and C equals 50. If you got this wrong, okay, you can pause the video and have a go at the rest of the question from now on. BI. Given that on a particular journey, the fuel tank was initially full and the car continued until ran out of fuel. Find the initial volume. Initial volume means D is 0 because that means you've traveled no distance. So when D equals 0, V equals to 50, and that's 50 liters. Part BI, find distance when the car traveled on this journey. So it ran out of fuel, was initially full and ran out of fuel. That means that now the fuel tank V volume is no longer full. So V has to be 0 because you got 0 liters left. So put a 0 in there, get D equals 400. Okay. Part C. In fact, the car only traveled 320 kilometers on this journey. Evaluate the model in light of this situation, of this information. This model is not very reliable because we calculated the car should have traveled 400 kilometers, right? If you use the full tank, 400 kilometers. But in real life, only traveled 320. So that's why, okay, it is significantly less. So we use the word not reliable, all right? Or we can use the word not very accurate, all right? Yeah, so that's the end of chapter 5, right? So, and that's it. And I'll see you in the next chapter about circles.